Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So up to now we have discussed about engineering tribology subject. So all previous sessions we have discussed about concept of engineering tribology and then various parameters like friction, wear, corrosion and lubricants. But and also discussed on question bank and then definition, terminology and model paper questions we have discussed. But in this session, I want to discuss about some numerical problems related to the surface roughness. The surface roughness value, how to calculate the surface roughness value in this tribology subject. So we will see the numerical problems related to surface roughness. In previous sessions, we have seen only the wear calculation, friction calculation, and the lubrication calculation. See, so in this, the surface roughness is crucial parameter in manufacturing and engineering, the influencing the performance, appearance, and durability of mechanical components. So very important the surface roughness. If not having that much of surface roughness, what will happen? The friction will be generated, and due to the friction, wear also possible, and then finally the component will fail due to the poor surface finish. So that's why the product, the component surface should be good surface finish, and then so how to calculate this surface finish? Well, how much required the surface finish value? That is the concept is surface roughness value. So in this, they influence the performance and also the appearance and durability of mechanical components. This life of the mechanical components depends upon this surface roughness values. So problem one, calculating the average roughness values. How do you calculate the average roughness values? So the emission surface has the following profile heights. The emission surface given the profile heights in micrometers. So measured at regular intervals. So 2, 4, 6, 3, 5 micrometers. Calculate the average roughness of the surface. So the average roughness value is RA. So he has asked in this calculating the average roughness value. So how do you calculate? So first sum of the heights. Sum of the heights. So how much the measured at a regular intervals. The heights are in micrometers. So first you take sum. 2 plus 4, 6, 3, 5. How much? Total 20 micrometers. So number of measurements are n is equal to 5. The number of measurements are 5 numbers. So 1, 2, 3, 4, 5. The average roughness value, so an average will sum upon 5. So that is 4 micrometers. So like this, the average roughness value will get. Next one, in this problem, this is very simple problem. So only you need to add these numbers and then take the average. Next, problem 2, calculating root mean square roughness. So root mean square roughness is represented with RQ. Consider the same set of measurements. Same measurements you take 2, 4, 6, 3, 5. 2, 3, 4, 6, 3, 5 micrometers. Calculate the root mean square roughness. Square the heights. Sum of squared heights. So square the heights and then sum of squared heights. First you need to square the heights. So square the heights, how do you calculate? And take average of squared heights and root mean square roughness. So calculating root mean square roughness means square the heights. So how many heights are there? One is 2 square and 4 square and 6 square and 3 square and 5 square. How much value this one? Calculate 4 plus 16 plus 36 plus 9 plus 25. So 20, 56, 65 plus 25, that is total 90. The sum of squared heights. Square the heights on the over, and first you have to need to square it. 2 square, 4 square, 6 square, 3 square, 5 square separately, and then add them. So you will get square the heights. Next one, sum of squared heights. The sum of squared heights already we have done, that is 90. Now average of squared heights. So what is the squared height average? So how much total? 90. So total 90 by the number is n. How many are there? This 1, 2, 3, 4, 5. So next 5. So you will get how many here? N means 18. 18 average of square heights. Now root mean square roughness. So that is R cube. So how do you calculate the root? Root mean square roughness. Take the surface average of square heights. It's the average of square heights. Average of square heights. That is 18. So we will get the value, root value approximately 4.35. Clear? So like this, you need to calculate the value of the root. So in the units are micrometers. The average roughness value in micrometers. So that is mm. All sum of heights mm. The micrometer. So sorry, micrometer mu m. Micrometer. So this value also in micrometer. So next one is the problem determining the surface roughness from a profilometer reading. So suppose a profilometer is there, you have readings. How do you calculate the surface roughness values from the profilometer reading? A profilometer measures the surface roughness of a sample and provides the following values for the peak to valley height. So that is PV. And then the average roughness, if the peak to valley height is 20 micrometer, that is mu m, and the average roughness is 4 micrometer. Average roughness is 4 micrometer. So calculate the peak to valley heights as a multiple of the average roughness. Peak to valley height as a multiple of the average roughness. So the profilometer measures the surface roughness of a sample and provides the following values for the peak to valley height. The average roughness value, if the peak to valley height is 20 micrometers and the average roughness is 4 micrometers, calculate the peak to valley height as a multiple of average roughness. So how do you calculate? The solution is peak to valley heights PV is 20 micrometers. Average roughness. The average roughness is 4 micrometers. The average of roughness is 4 micrometer. Multiple of average roughness is PV upon RU. So what is the average roughness? Now 20 micrometer given. So 20 upon 4. So we will get 5. So the peak to valley height is 5 times the average roughness. Clear? So in this, a profilometer measures we have. So by using this, you need to calculate surface roughness. So what is the final surface roughness? The multiple of average roughness, the value is 5. Now peak to value height is 5 times the average roughness. Clear? So that is the solution for this problem. Next problem for estimating surface roughness from cut depth. Suppose having any cut depth, a turning operation is performed with a cutting depth of 0.2 mm. If the cutting tool creates a roughness of 2 micrometers for 0.1 mm of cutting depth, estimate the surface roughness for the given cut depth. So what is the estimation? Estimate the surface roughness for the given cut depth. The turning operation is performed. So the depth is 0.2 mm. So this the turning operation you can see in mechanical machinery. In mechanical machines, lathe machine is there. By using lathe machine, you can perform this operation. That creates a roughness 2 micrometer for 0.9 mm. So now how to calculate? See the roughness for unit cutting depth for roughness for 0.9 mm is 2 micrometers. The cutting depth is 0.2 mm given in the problem 0.2 mm. And then the surface roughness 2 micrometers. 2 micrometers into 0.2 1 by 0.1. The roughness the value for cutting depth you will get 4 micrometer. This is the estimated surface roughness is 4 micrometer. Estimated surface roughness. So like this you have to calculate the roughness for cutted material, cutting depth. Next, converting surface roughness units. The convert a surface roughness value of 6 micrometer roughness value to micro inch roughness value. So roughness value is 6 VN RA to micro inch RA. The solution is conversion factor. That is 1 micrometer 39.37. 1 micrometer is equal to 39.37 micro inch. The conversion is the surface roughness mu inch is equal to 6 micrometer multiply with 39.37. So this value substitute here. You will get a value micro inch for micrometer 236.22. Therefore, a surface roughness of 6 micrometer roughness value is approximately 236.22 micro inch roughness value. So like this need to calculate the converting surface roughness units. So in this topic you have seen calculating the average roughness values, and then so very simple, take the sum and then take average of calculated sum and calculate root mean square. So root mean square first you need to determine the square the heights and then take the sum of squared heights. So you will get a total value and then take the average of squared heights. So you will get a value, that value, so square root apply. So root mean square roughness value is value occur. So obtained by this equation. So next one is determining the surface roughness from a profilometer reading. So profilometer reading already shown the peak to valley heights. The peak to valley height is 5 times the average roughness values. So already you have calculated here 5. Height is 5 times the average roughness. In this problem, surface roughness from cut depth. So very rare this type of problems will not ask in examinations. So sometimes very rarely they will ask. The turning operation is performed with a cutting depth of 0.2 mm. So like this they will go. So what we have did? So applied this formula. The roughness for 0.2 mm. So cutting depth. The roughness is equal to 2 micrometers upon multiply with 0.2 upon 0.1. So next converting surface roughness units. The conversion is important is 1 micrometer is equal to 39.37 microinch. So this is very important. So remember this point. So conversion surface roughness is equal to mu inch micro inch is equal to 6 micrometer into 39.6 micrometer given. So now 6. So 1 micrometer is 39.37 mu inch. So, but here 6 micrometer. So that is how much for 6 micrometer? 6 multiplied with 39.37. So that is the value given in the approximately 236.22. So like this, need to calculate the surface roughness values. So why? Because this surface roughness, surface finishing is very important in mechanical engineering or any surface. So that is the surface depends upon the acidic, material used, selection of materials, operating conditions, and then operating missions, which type of operating you are performing. So based on the performing operation also affect. So this the surface roughness values. So that's why how much required the surface finish for so particular material. So based on that condition, need to calculate roughness value, and then you have to apply the finishing surface of finishing methods. If not having the surface smooth surface finish, what will happen? You will get friction. Due to the friction, where the some material will be removed from the metal surface, and then fatigue cracking also will be developed on the surface. That small crack gradually initiate to the failure of the component. So already we have studied fatigue properties. To those things, to avoid all those things, failures, need to apply the surface roughness formulas and to calculate. First, you need to know the surface roughness values. So these are the references I have taken for this calculation for this problem, roughness problem. So that in this topic, so the problems related to engineering tribology. So the friction problems and bearing problems we have seen in a previous session. In bearing problems, how to calculate the minimum bearing load, how to calculate the minimum oil film thickness, and then how to calculate the wear volume by using pin on disc method. So we have studied this pin on disc experiment in wear mechanism. So wear measurement methods. So pin on disc is one type of method to calculate the wear of the particular surface. So before selecting the material, first you need to test the wear test. So how much wear will be occurred for particular load. By changing the load and by changing the distance, you can the values may be vary. So based on that values, after you take a number of samples testing, and then those values you can you can say you can say the optimal material for the particular application. So that's why the pin on disc testing method is used to calculate the friction wear. And this machine is two types are there. One is at a dry condition, another one is in a wet condition. So in dry condition, where there is no lubrication in between the plate and the pin and the plate. So rotating disc. So in the case of wet lubrication condition, so wet lubrication condition, there is a lubrication between these two. By using lubrication, so how much wear happen? So without lubrication, how much friction, how much wear developed? So these things you can calculate. So that's why all these problems, all these formulas, so first you need to apply for the calculation part only. So how much wear occurred, how much load is required, how much film thickness is happened. So by experimentally you can calculate. So that's why every engineer, every design engineer should know about properties of materials and about testing methods, and how to calculate the calculation procedures, formulas need to learn. So that's why we have discussed in this session related to this topic. Okay, these are the references I have taken. You can go through. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.